hit record. So that's it.
Dot count method, let's count the amount of dashes. So place a character within the count method. This method will return an integer. Let's store that within a variable. Result equals phone number dot count method. So type in some phone number, 1-234-567-8901. We have 3 dashes within the string. 1, 2, 3. That is the count method. We can count how many characters are within a string. We also have the replace method. Honestly, the replace method is probably one of the most useful methods of strings. We can replace any occurrence with one character with another. Replace, let's replace any dashes with maybe a space. This method will return a new string. I'm going to reassign this to our phone number variable. Then print the phone number. Enter your phone number, 1-234-567-8901. So here's my new phone number, but we've replaced all of the dashes with spaces. Even better yet, we could eliminate all the dashes completely by replacing the dashes or another character with an empty string. 1-234-567-8901. Here's our new phone number without any dashes. We've replaced all dashes with an empty string, no characters. If you would like a comprehensive list of all of the string methods available to you, you can use the help function, type in the data type str, meaning string, then I will print whatever the result is. Here's a bunch of methods you might be interested in. In the future. Capitalize, casefold, center, count, encode, ends with, just to name a few. Alright everybody, here's an exercise for you. We will validate some user input. We would like a user to enter in a valid username. However, there's a couple of rules. The username can be no more than 12 characters long. The username must not contain any spaces, and the username must not contain any digits. Let's assign a variable named username equals input. Enter a user name. First, let's check to see if our user input is more than 12 characters long. We can do that using the length function. We will find the length of our username. The length function returns an integer. Let's check to see if the length of our username is greater than 12 characters. If it is, we'll print a message. Your username can't be more than 12 characters. Else, we will print using an F string, welcome, whatever our username variable is. Let's try it. I'll type in my first name, last name, then add a whole bunch of characters afterwards. Your username can't be more than 12 characters. Let's type in something that's under 12 characters. Yep, and that appears to work. Okay, so we have accomplished task number 1. Our username can't be more than 12 characters. Next, our username must not contain any spaces. We can use the find method of a string. Username.find. We will find any spaces. That's a character. If no spaces are found, this method will return -1. Using an else if statement, I'll add not. If the find method of username equals -1. If the result is not -1, meaning we found a space, we will print your username can't contain spaces. I'll type in my first and last name. You might need to think of something that's underneath 12 characters. Your username can't contain spaces, so we have accomplished rule number 2. 3. Username must not contain digits. We can use the isAlpha method of strings. The isAlpha method returns a boolean if a string only contains alphabetical characters. So let's copy that. I'll add another else if statement. Not username isAlpha. Then we will print your username can't contain numbers. I guess technically isAlpha would check for spaces too, but I'd rather have that be handled within a different if statement. Contain number. Copy that. I'll add it. The isAlpha method returns a Boolean if a string only contains alphabetical characters. So let's copy that. I'll add another else if statement. Not username isAlpha. Then we will print your username can't contain numbers. I guess technically isAlpha would check for spaces too, but I'd rather have that be handled within a different if statement. Alright, I'll type in a username. I'll include some digits. Your username can't contain numbers. Alright, I think we've accomplished this. Let me make up a username following these 3 rules. Yep. It seems to check out. Alright everybody, and that is a few useful string methods that you may be interested in. Hey everybody, in this topic I'm going to explain string indexing. Indexing allows us to access the elements of a sequence using a set of square brackets, also known as the indexing operator. Using this set of square brackets, following a string, there are up to 3 fields that we can fill in. We can access a starting point in the string, an ending point, and a step. Here's an example. Suppose we have a credit card number. Credit number equals, and I'll just make up some number. 1234-5678-9012-3456. Good enough. If I need the first character within the string, I can type the name of my string variable, followed by the indexing operator, which is a set of square brackets. The first position has an index of 0. Computers always start with 0, so that's why the first index is 0. Then I'm going to go ahead and print this. Print credit card number at index of 0. That would be 1. If I were to change the index to be 1, 0, 1. That should be 2. Index 2 would technically be 3. Then 4 is the dash within our string, as you can see here. With the indexing operator, there's up to 3 fields that we can fill in. A start, end, and step. If you have just one field listed without any colons, it's assumed you're filling in the starting position. So now what if you would like the first 4 digits of the string? Well, we would type the name of our string variable, indexing operator. We'll need a starting index, colon, then an ending index. The first 4 digits would be 0, colon, 4. Then I will print this. And I'm just going to turn this first line into a comment. Yeah, there we go. We have the first 4 digits of our credit card number. 1, 2, 3, 4. Just so you know, with the ending index, this index is exclusive. This first number would be 0, 1, 2, 3, 4. So we did not include that dash within the number. The starting index is inclusive, the ending index is exclusive. So you can omit the 0 in the beginning. You could just say colon 4. Python assumes the starting position will be the beginning of the string. So that would work too. Let's get the next set of digits, 5, 6, 7, 8. Credit number, indexing operator. Let's find where the starting index would be. 0, 1, 2, 3, 4, 5. 5, colon, 6, 7, 8, 9. Then we will print whatever is here. The next set of digits is 5, 6, 7, 8. Maybe we need the last 12 digits. Well, what we could do in that case, we will take our string variable, credit number, set the starting index to be, let's see, 0, 1, 2, 3, 4, 5, 5, colon. If you need everything up to the end of the string, you don't need to list an ending index, just be sure to add that colon. Python then assumes you need everything up to the end of the string. So I will print whatever we have. Then we should have everything besides the first 4 digits. Yep, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. You could also use a negative index. Credit number. If you need the last character in a string, you would set the index to be -1. Then I will print this. Print credit number at index of -1. That would be 6. -2 is 5. -3 is 4. -4 is 3. And then -5 would be that dash right here. Yeah, you can use negative indexes too. Let's talk about step. Using the step field, we can access the characters in a string by a given step. We can count by 2s, or we can count by 3s. So here's an example. So let's take our credit number. If we're not filling in the starting or ending fields, but we need a step, we would need 2 colons then. Python is assuming everything from the beginning of the string to the end then. Our step will be 2. This will print every second character within our string. Yeah, here we are. We have 1, 3, dash, 6, 8, 9, 1, so on and so forth. If I were to change the step to 3, we would count every third character, beginning with 1, 4, 6, dash, 1, 3, 6. Alright, here's a practical example. Let's create a program to get the last 4 digits of a credit card number. I'm going to assign this to a new variable. Last digits equals our credit number, indexing operator. So we need the last 4 digits. Where would the starting index begin? Well, we could use negative indexing. This last digit is -1, -2, -3, -4. We will begin at -4. Colon. We can omit the ending index. Python assumes we need the rest of the string then. Really, that's all we need. So let's print. I'll use an F string. Maybe some X's. Maybe we're hiding somebody's credit card number except the last 4 digits. Okay, then. Variable, last digits. Alright, and here's our credit card number, where only the last 4 digits are visible. Hey, you know what? Let's add one more exercise. Let's reverse the characters in the string. I'm going to reassign credit number equals credit number. If we need the entire string, we don't necessarily need a starting index or an ending index. But for the step, this will be negative. -1 will reverse a string. Then let's print whatever our new credit card number is. Print credit number. And yeah, there is our credit number backwards. To reverse a string, you set the step to be -1. So yeah, everybody, that is string indexing in Python. We can access elements of a sequence using the indexing operator, which is a set of straight brackets. You can list a starting position, ending position, and even a step if you need to skip over characters. But yeah, that is string indexing in Python. Hey everybody, in this topic I'm going to explain format specifiers. Format specifiers, when used in the context of an F string, they allow us to format a value based on what flags are inserted. Following your value, you would type a colon and then some flags. Depending on what flags you insert, it will format your output a certain way. You could add decimal point precision, allocate space, zero pad values, left justify, right justify, center align, all sorts of things. Let's have some practice. I'll create 3 prices. Price 1, price 2, price 3. Price 1 will be 3.14159. These values aren't in dollars and cents yet, but they will be. Price 2 will be negative 987.65. As you can see, I'm just making up numbers here. Price 3 is 12.34. Let's display our prices using some F strings. Price 1 is placeholder price 1. Then we will do this for price 2 and price 3. Price 2 is price 2. Price 3 is price 3. Within our placeholder, following the value, we can add a colon, then some flags. Those flags are the format specifiers. They will format our value a particular way depending on what we insert after the colon. To add decimal point precision, you would type, after the colon, dot, then the amount of decimals to be displayed, maybe 2, then F meaning floating point number. Let's do that with price 2 and price 3. Colon, dot, to F. Price 1 is now 3.14. Price 2 is negative 987.65. Price 3 is 12.34. I think I'm going to add some dollar signs before the placeholder. Yeah, that's much better. For less precision, maybe 1 decimal place, you can change the 2 to a 1. So 0.1F. Each number only displays 1 decimal. 0.1, 0.6, 0.3. Whereas in 0.3F would display 3 decimal places. 0.142, 0.650, 0.340. Even though price 2 and price 3 only have 2 decimal places in the original numbers, we will concatenate some additional zeros. To allocate space to display a value, after the colon, add some number for that many spaces. How about 10? Each value now has a total of 10 spaces to display the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you were to precede a number with 0, well, these numbers would be 0 padded. Each number is now 0 padded. To left justify a value, you would use a left angle bracket. All these numbers are now left justified. Then we have all of the space after. They're all uniform. Right justify would be a right angle bracket. And I believe that's the default. Center align, I believe, is the caret symbol. Yep, our numbers are now centered. If you have any positive values, and you would like to display a plus sign, just use plus. Any positive number is preceded with the plus sign, any negative number is preceded with the negative sign. Or you could use a space for any positive numbers. So colon, space. These numbers are lined up evenly, even though we have a negative number in here. There is a thousand separator, which is a comma. We should probably increase the value of our prices. 3,000, negative 9,870, 1,200. Each thousands place is now separated with a comma. We could also mix and match flags. I would like a thousand separator, along with decimal point precision of 2 decimal places. And why not? I will precede each number with a plus sign if it's positive. Yep, here we are. So based on what you're looking for, you can add some combination of flags. So yeah, those are format specifiers, everybody. Within your placeholder, insert your value. Based on what you're looking for, you can add some combination of flags. So yeah, those are format specifiers, everybody. Within your placeholder, insert your value, a colon, then certain flags based on what you're looking for exactly. But yeah, those are just a few format specifiers in Python. Hey everybody, in this topic I'm going to explain while loops. A while loop will execute some code while some condition remains true. Here's an example. We'll use an if statement first. We will ask a user for the